So in this video, we are going to discuss some problem on convolution. So they given the x of t value in the graphical method. So the h of t value also it is given. So they are asked to find the y of t. So the formula for this one is y of t is equal to x of t convolution h of t. So I'm going to do it with the help of graphical method and verify it using a Laplace transform. Okay. So the formula is minus infinity to infinity x of tau h of t minus tau d tau. Okay. So this so first I'm going to convert this since it is in the range of t. So I'm going to convert it into x of tau. So the x of tau will look like this, right? So instead of t, I'm going to draw it like this is my x of tau. Just change it. This is my x of tau. Similarly, if I take it, this is my h of tau L, right? This is my h of tau L. So if I want to plot h of minus tau, so here this here I have to multiply -1 with this one. Okay, so this is called a scaling, right? So I'm going to multiply with this one. Okay, so if I multiply minus with this with this one, it has to be -1, right? Next, I'm going to add h of. So I want to get h of t minus tau. So for this one, if I add, t, h of minus t plus t. Okay. So what I have to do, add t with this one, this becomes t and this becomes t minus tau. Okay. So I can take somewhere like this t and this is t minus 1. Okay. So now what I'm going to do, so I'm going to multiply these two things, right? So the formula is if I multiply with those two things, it has to be 0, right? So you can see if I multiply with this one obviously my x of t is equal to 0 for, okay, y, since the t can take any value, right? So if it takes less than 0 only, the y of t is equal to 0. Why? Because if t is equal to -1, if I consider t is equal to -1, so this has to be ranges from -2 to -1. So if I multiply with this one, obviously I will get the answer as 0 because there is no intersection, right? So similarly, if I take t is equal to -2 also, this becomes -c2 -2. So again y of t is 0. Okay, there is no intersection, right? So now what I'm going to do is so if I take this is my x of tau value, right? This is my x of tau value. So it ranges from 0 to 1 and magnitude is 1. So now I'm going to intercept with this one. So this is my h of t minus tau. So suppose there is an intersection with this one. So the intersection is from, so to find the y of t, the intersection is from 0 to t. The amplitude of x of tau is 1 and h of t minus tau is 1, right? This is multiplication, right? Tau is 1, d tau. So if I solve, I will get tau of 0 to t. So if I substitute, I will get answer as t. So if I want to have an intersection like this, so obviously t must be, So the y of t is equal to t. So t must be greater than 0 and it has to be less than 1 because if I substitute t is equal to 2, okay, if I substitute t is equal to 2, I won't get this kind of graph, right? So the t must be less than 2. So this is the second case, right? And the third case is, this is my x of tau, right? This is my x of tau value, and there may be a possibility that h of t minus tau plus t will be looking like this, right? So there is a possibility of intersection like this. So my y of t is equal to, the intersection is from t minus 1 to 1, x of tau value is 1, and h of minus tau plus t is also 1 d tau. So you will get tau of 1 t minus 1. So this is 1 minus t minus 1. This is equal to 2 minus t. So y of t is equal to 2 minus t for t greater than 1, right? Because up to 0 to 1, this must be 0 to 1, right? So it should not be greater than t of 1, right? So if I substitute t is equal to 1, so there may be intersection like this, okay? So if I substitute, it should be greater than, it should not be greater than 1 or equal to 1. So it should be less than 1 in order to get the graph like this. So if it is greater than 1, I will get the intersection like this. So if I substitute, t is equal to 2. So if I substitute t is equal to 2, I will get this is 1, this is 3. So this is 2. Okay. So if I substitute t is equal to 3, okay, this is 2. So I will not get the answer like this. So therefore the t value, it ranges from 1 to 2. Okay. So I can write answer as y of t is equal to 0 for t less than 0, and this is equal to t for 1 less than 0 less than t, it is less than 1. Next it is 2 minus t for 1 less than t, and t less than 2. Okay. So how to draw this one? So my y of t is equal to 0 for t less than 0. So for this entire part it is 0, and up to 1 it is t. Okay. So this is 1. So if I substitute t is equal to 1, y of t is also 1. So 2 minus t, how to draw 2 minus t? So if I substitute t is equal to 2 or less than 2, it becomes 0. So you see my signal will look like this. This is my y of t. Okay. So they have given the x of t. Let us verify it with the help of Laplace transform. So to find the Laplace transform of this one, so we know that the x of t is equal to u of t minus u of t minus 1, right? Since the u of t look like this is my u of t, okay? This is my u of t, and this is nothing but u of t minus 1, right? So this is u of t minus 1. So if I subtract, you will get these kind of waveform, right? This type of waveform. So similar way I can write h of t also the same value, right? U of t minus u of t minus 1. since both values are same. So what is my x of s? So if I uh, take a Laplace transform, this is nothing but e power minus s divided by s. Okay. So my h of s is equal to h of s is also it is nothing but 1 minus e power minus s divided by s. Okay. So I need to find the value of x of s, right? X of s is equal to h of s into x of s. So if I multiply this two thing, I will get 1 minus e power s divided by s square the whole square. So is equal to 1 minus e power minus s the whole square by s square, right? So how to write this one? 1 minus 2 e power minus s plus e power minus 2s divided by s square. So this I can write it as 1 by s square minus 2 into e power minus s divided by s square plus e power minus 2s divided by s square. Okay. So this is nothing but t minus, right? Yeah. This should be 2 into t minus 1, right? Plus t minus 2. Okay. So instead of t, I am going to write it as r of t. Okay. R of t minus 2 of r of t minus 1 plus r of t minus 2. So how to draw this one? This is my x, y of t. So how to draw? So since you can see the Laplace of t is 1 divided by s square minus 2 into t minus s. So t minus 1 I can write it as 1 divided by s square into e power minus s, right? So this is how we have to write. So instead of t, I am going to write it as r of t. So how to draw this one? So this is y of t. So this is nothing but r of t. Okay, this is nothing but r of t and minus 2 of r of t minus 1. So from 1, I am going to draw minus, right? So it has to be uh, comes down, right? So this is my minus of right minus of 2 of r of t minus 1 t minus 1. So next from 2 I have r of t minus 2. Okay. So this goes on. Okay. Goes on. So if I add this one, okay. So I get this is my r of t from this is my r of t minus 2. If it is minus r of t minus 1, the signal will be like this. Okay. Minus r of t minus 1. So suppose if it is minus 2 of r of t minus 1, it has to be like this. Okay. It has to be like this. So from 2, I have plus r of t minus 2. Since it is goes on like this, from here I have to add r of t minus 2. This is 2. Okay. So if I add r of t minus 2, it has to be like this. Okay. The final answer has to be like this. So this is how you have to draw it and verify it with the help of Laplace transform. So I hope this video is useful for you. Thank you.